Hello everyone, good morning, good afternoon, good evening, depending upon when you're watching this video lecture. Today, let us discuss about one of the very crucial concepts in the financial management, that is time value of money. This is a very important concept, the application of which can be seen at multiple places in the financial management and other financial planning and capital budgeting related aspects. So the application of which can happen at multiple places, but the concept is same, and definitely a very strong understanding of the concept of time value of money is very important for actually using it in other aspects, including bond valuation, computation of value of any asset for that matter, value of business, value of an equity share. So that is from the corporate finance point of view, and even in the investment decisions point of view, which are naturally the long-term investment decisions, in order to compute NPV, the net present value, or IRR, the internal rate of return of any project or investment, and other DCF techniques like discounted cash flow techniques. All of these places, the concept of time value of money plays a very crucial role. And let us focus on the conceptual area of this aspect, that is the time value of money. First of all, what is time value of money? Time value of money refers to the changes in the value of money across the various periods of time. If you just take a simple example, say someone offers you to give $100 today or $100 after 3 years. Which one will you prefer? Simple question. Naturally, we will say definitely getting $100 now is better than getting the same $100 after 3 years. Why is that? Why do we do that? Of course, this can be even called as time preference, but that will automatically be happening because of one of the reasons, that is time value of money. So what is the concept here? Why do we prefer it now rather than after 3 years? Because the amount you are receiving is same. Amount you are receiving is not different. You are not receiving any lesser amount after 3 years. You are receiving same $100. But why do we want it now? And why don't we want it after 3 years if option is given to us? Because first point is, our thought process will be like, boss, if I get the $100 now, it has to be like this. Not necessarily that it will be the same way for everyone, but financial management point of view has to be like this. If I get the $100 now, there is a possibility that I can invest this $100 and I can get some interest on this $100 for a period of time, in this case which is 3 years. So imagine if I get $100 now and if I keep it for 3 years, is it going to remain $100? No, it is not going to. Definitely it is going to increase. How? Because of this main concept of interest. Okay, should we talk about only interest? Not necessarily. In this case, at a conceptual level, it could be any return that is possible on the investment. If I invest in any of the equity shares, I may get some return. If I invest in bonds, I can get some other return. If I invest in bank deposits, I can get some other return. But definitely I will get some return. on this money over a period of time. So the logic is same, interest rates, percentages, they may vary, but the logic is same. The $100, if I have it now, I can definitely make some money with this money because of this money being with me for a period of time. So there is a time here, and the value of money is created on the value of money, on the original money. So that means there is money, and applying these two things put together, that is the time value of money. So what is something which changes its value over a period of time is definitely money, for sure. What other things will change? Anything can change. Any other asset also can change its value over a period of time. We are not talking about that. But essentially, the value of money keeps on changing over a period of time. Why is that? Because of basically the concept of interest. But again, when we look at interest, we should not think about only interest. Interest is one form of return on investment, but there could be other forms of return on investment also. But even then, since we need to keep the things simple for understanding purposes, let us consider why this value of money is changing over a period of time. One of the major reasons is definitely interest. That is for sure. Is it the only reason? Though definitely not. There is another reason, which is risk. Same question, if you go back, why do you want $100 now, not after 3 years? Because in the following 3 years, anything can happen. Maybe the world will end, maybe we may not be existing to receive that money. We don't know. Anything can happen because future is uncertain. We don't know what happens in future. And naturally, uncertainty also quantifies itself into risk. So there will be risk involved with time over a period of time, particularly when we are talking about future. Past is never risky. Past is over already. So future is always risky. Why? Because we don't know what happens. So that is another point. And not only that, another important point also is inflation. Inflation is the inherent changes in the value of money within a country. Within a particular country, inflation also plays a role in understanding the time value of money. One of the aspects is interest, as we just now discussed. What kind of role it plays? What is the logic behind that? I would say, if I have $100 with me for a period of 3 years, I can earn some interest on that. Just to take a simple example of a simple interest. Of course, compound interest is also possible. We'll come to that later. But just to take a simple example, let us say 5% interest rate is there per annum. Okay. And annual interest, that is. Like that for 3 years, how much interest you can get on this $100? Each year you can get $5, 3 years $15. That means the 100 originally what you had some interest now. Now at the end of 3 years you can have $115. So naturally, why would you settle for receiving $100 after 3 years? No logic. That is why you don't want $100 after 3 years, you want it now, because at the end of 3 years you have an opportunity of getting $115. So naturally, I would like to have it now and then earn some interest on that, so that in future my original money has become little more. And how is that becoming more? With interest. Without interest, it is not possible. Imagine if the interest rates are 0, then it doesn't make any difference. If you get your money today or tomorrow or whatever the time period may be, it doesn't make much of difference. If the interest rates are 0, then time value of money may not have much of significance. Of course, that does not mean other factors will not play, but interest itself may not be the major role. But in that case, what can be the role that is played by other things? So there we can replace this with some return on investment which can be expected. Whatever that return might be. It could be in the form of interest, it could be in the form of any dividend, or it could be in any other form. Whatever the way that you can invest that money and get more money which earns itself on the money. So the point of money, earning money, is a very important aspect. How is it earning is different story. For simplicity purpose, we always take interest as one of those factors. That is one thing. Risk, definitely yes, because the future is risky. So rather than waiting for 3 years to get the same $100, I would prefer to get it now. Why to take a risk of 3 years for the same amount? It doesn't make sense. So definitely I would not settle for receiving $100 after 3 years, because I would be better off receiving the same $100 now, because receiving it now is less risky. Receiving after 3 years is more risky. That is another factor and another aspect. And another aspect is inflation. Of course, this changes from country to country, economy to economy, but the concept is there. What is inflation generally is the rising prices. The rising prices of commodities. Let us, for example, say now, just for example, now with this $100, let us say you can buy now, say just for example, if you take any of the commodities, like the basic necessities, like the basic necessities of food, etc., or food, clothing, etc., whatever they may be. But let us say, just for understanding purposes, let us take clothing. Let us say same type of clothing with the same $100. Now you can get, say, 4 pairs of clothing. But will you be able to get the same 4 pairs after 3 years also? Probably not. Why? Because the prices of this clothing might rise in the 3 years. Why it will rise? Will it always rise? Not necessarily. But will it rise? In general, yes. Why does it happen? It is because of inflation. So now probably you might get 4 pairs of clothing, whatever it might be, with $100. After 3 years, with the same $100, let us say you are able to get only 3 pairs. In other words, for example, if you have to get same 4 pairs after 3 years, with $100 you can get 3 pairs only. How much money you will require for 4 pairs? 100 by 3, each pair cost, multiply with 4. So 100 multiplied with 4 by 3. In other words, you need $133.33 if at all you want to buy the same 4 pairs of cloth, which you can buy now at $100, but after 3 years you might need $133.33, which means, once again, the intrinsic value of the money, the inherent value of the money, the purchasing power of the money has reduced. When the purchasing power of the money itself has reduced, then you need more number of units of money to purchase the same commodities and services after some time. So, and this again, due to the inflation over a period of time, definitely can be observed in many economies. Of course, some economies may have a very higher inflation, some economies may have very lower inflation. We took this as only an example. Not necessarily that United States of America, that much expenses will be there. Not necessarily that much inflation is there really prevalent in USA. Not necessary. It can change. It can be only 2%, 3%, or maybe less than that. In some countries, the inflation rates touch double digits also. Depends upon the economy. But whatever it is, we are not sticking to one country here. We are talking about a concept. When we talk about a concept, that applies to throughout the world. A plus B whole square is the same formula throughout the world. H2O, formula for water, same throughout the world. In USA, water is H2O. In some other country, water is H5O. Not like that. Everywhere it will be H2O only. That is the formula for water. Same way, these things which are conceptual, scientific, they will be same across the world. Only what changes here in the financial terms is these numbers will change, because this is not exactly like chemistry. So in US, maybe the inflation will be lesser. Let us say some other countries, like developing countries like India, inflation rates may be higher. Fine, that is different. But will there be inflation? Generally, yes. Mostly, yes. So what happens because of that? The purchasing power of money reduces. When the purchasing power of money reduces, the money required to buy the same commodities will increase. So in our example, now with our $100 we can buy 4 pairs of clothing, but after 3 years with the same $100 we can buy only 3 pairs. So which is better for us? Definitely this is better for us. Why? Because you are not going to get the same kind of commodities or services after 3 years with the same quantity of money. So why would you wait 3 years to get a lesser quantity of commodities or services? No, you will not. So this is not a good proposition. Why is it not a good proposition? Again, because of now, in this case, inflation. The same thing is not a good proposition because of interest also. The same thing is not a proposition or a good proposition because of even risk also. Same thing is not a good proposition even from the point of view of inflation also. All the three will be inherently there in the time value of money. But once again, are we going to look at them separately? How much of inflation will be impacting? How much of risk will be impacting? How much of interest will be impacting? Can we do that? Probably yes. In reality, it is possible to segregate them, but that requires a lot of mathematical exercise. Do we need to do that? We don't need to do that. So whatever we are talking about here as the time value of money concept, here, whatever is that return we are talking about, that we have to assume, and that is also a fact, that it will include all the three factors. It will include them. For example, are interest rates free of inflation? No. Interest rates already include inflation. Why? Because the interest rates, if they are not inclusive of inflation, then those are real interest rates. The interest rates which are inclusive of inflation are nominal interest rates. Normally, if you go to a bank and say that I want to deposit money with your bank, how much interest you will give? He will say 4%. Is it a nominal interest rate or a real interest rate? It is a nominal interest rate. It is a nominal interest rate. So everything that is expressed normally in the world is nominal. Real could be different. Real could be lesser than that. Why it could be lesser than that? Because of inflation. In other words, interest already is inclusive of the inflation. Is that already inclusive of the risk? In general, yes. Inflation is included. Interest rate, base interest rate is included. Risk is also included. Let us say, take the same example once again. Let us say if you go and buy a US Treasury bond. US Treasury bond. Let us just for example take interest rate is 3%. Okay, that is generally considered as a risk-free interest rate. Will you invest in some of the bonds of a normal corporation, a private corporation, if it offers the same 3%? No, you will not. You will not invest. Why? Because you need some premium for risk also. So this 3% already included inflation, and this 5% already included inflation and risk also. So whatever the rate that we are talking about, at which the time value of money changes, that rate normally includes all the three conceptually. We don't need to separately look at them unless it is required. But conceptually, every rate that we are talking about, any rate of return that is required, that will be inclusive of interest or base rate plus risk plus inflation. Already all of them are included in that. That is the first point to be noted. So keeping all of them in one place, now we can definitely safely conclude that this $100 after a period of 3 years will become 100 plus something. For sure. How much is that something? That depends upon, once again, all the three factors. That depends upon how much is the interest rate, how much is the inflation, how much is the risk. That depends upon various factors. But again, we don't need to segregate all of them. All of them imbibed into interest rate only, let us assume, which is partially true also. Let us say, now for an example purposes, interest rate is 6% per annum. Okay. So now this 100 becomes how much after 3 years? 100 becomes how much? 100 original principal amount will be there plus interest. Here the question comes, is it a simple interest or compound interest? If it is a simple interest, it is easy. How to get the simple interest? Whatever the original principal amount multiplied with rate of interest. Rate of interest here is 0.06. 6% means 0.06 multiplied with the time period, because this is per annum 6%. How many time periods are there? 3 years are there, means 3 time periods are there. That's all. So how much will that be? around $18. So the 100 becomes 118 if it is a simple interest. So what do we call this 118 as? It is the future value of 100. What do we call this 100 as? It is the present value of 118. That's it. So what is the future value of the 100? That is 118. What is the present value of 118? That is 100. But are these two happening at the same time period? No. This is happening now. This is happening after 3 years. That is the concept of time value of money, which involves present value and future value, as simple as that. However, the interest rates generally will not be simple interest rates. That is why this becomes a little complicated, little. Only when we understand it very clearly, it is not complicated. If we don't understand it, naturally it looks complicated. But for a simple interest, computations are also very simple. Let us first focus on simple interest and then we'll move on to compound interest and other aspects of time value of money also. So that is a point here to be noted. First of all, whenever the money is borrowed or invested, both cases, see, this is always having a two parties. Anywhere in the world there will be two parties. There is a party which is borrowing the money and there is a party which is lending the money or investing the money. Always will be there. But what is the original amount of the loan or investment? That is the principal amount. Okay. On this principal amount, there has to be interest that is calculated. How it will be determined? Definitely for the period of time. Interest definitely is going to be affected by the period of time. Time is a very important aspect for interest. That's what is time value of money we are talking about. So time matters a lot. And interest rate has to be also understood. And interest rate can be expressed in many ways, but usually interest rates are quoted as annual interest rates. If let us say some question says interest rate is 6%, so we don't have to again break our head. Is it per annum? Is it per 6 months? No. If nothing is mentioned, interest rate generally without anything else, any suffix, automatically it has to be taken as per annum. If it is given particularly as per month, then it is okay. Then it is per month. Otherwise, always interest rate has to be taken as per annum. If, for example, it is given as 1% per month, if at all, as an example, then automatically it is equivalent to 12% per annum because there are 12 months in the year. So, this conversion of per annum to month, month to annum, these things are very simple computations that have to be done. Anyway, so the time value of money definitely is going to be impacted by interest. That is the first point we should remember. Why that happens, as we observed already, because of three reasons. One, the return that you can generate by investing the money elsewhere. Two, risk. Three, inflation. But all these three are already included in the interest is what we have to always assume and use that concept while we solve the questions or do the calculations. Now let us just simply focus on the simple interest. Simple interest is the one which is just computed on the amount of the principal only that is outstanding. So the unpaid interest is not added to the principal. In other words, there is no interest charged on the unpaid interest. There is no interest on interest. In our example, what I have taken here. Here, every year, $6 interest is coming. Did we add it to the principal and calculated 6% on that again in the second year? No, we did not. So we directly calculated this $6 per year like that, 3 years. So automatically $18 is the total interest. Simple. That is a simple interest, which means, in other words, there is no interest on interest. Interest is only on principal. Interest on principal only is calculated. Interest on interest is not there if it is a simple interest that is offered, or that is what we are using for any of our calculations. Oh, we don't need big formula and all that for this, but still, if at all, let us take this one as a formula for computation of the interest. Of course, principal amount has to be the first one. Interest rate has to be taken, and interest rate has to be taken in per annum terms. Okay, then multiply with the number of days the principal is outstanding divided by the number of days in a year. Usually we can take 360, sometimes it can be 365 days also. In financial management, usually we can take 360. That again depends upon the question. If it clearly says 360, take it. Otherwise, 365 is also okay. That is the interest. Of course, if the number of days the principal is outstanding is generally less than 1 year, we can use this formula. Or simply, we can even take this way also. Principal amount, interest rate into time period. So PIT can be the formula for simple interest. Whatever the denotions you use, simply you have to understand the concept of it. Principal amount multiplied with interest rate multiplied with time period, whatever the time period can be. If interest rate is per annum, in our example, interest rate was 6% per annum, like that 3 years was there, so multiplied with 3. So what did we do here? 100 is P, this is I, this is T. Since it was years, what if it is days? Then we will take number of days the loan is outstanding divided by 360. Why? Because usually we take the interest rate as per annum. Let us look at an example for understanding purposes. Say there is a loan that has been taken or given, $100,000 is the principal amount of the loan. Simple interest rate is 6%. So what is the situation? If the entire $100,000 was remaining outstanding, which means not repaid for the entire year, what is the amount of simple interest at the end of the year? For the entire year will be how much? Simple direct computation. $100,000 which is P, 0.06 which is I, and full year it was outstanding. So 360 by 360 is 1. So no need to multiply with 1. Simply $100,000 into 0.06, $6,000 is the simple interest. What is going to be the interest for each day? Each day. If the entire $100,000 is remaining outstanding, then simply whatever the amount $6,000 we got divided by 360 or 365 as the case may be, you can take. So 6,000 divided by 360, around $16.67 per day is the interest, that is rounded to 2 decimals per day interest. That is usually in finance we take 360 days a year. Of course, there is no rule like that. We may take 365 days also, and even if we take monthly, then we can take 12 also, as the case may be, depending upon the situation. That T will change. P is okay, that is principal. I is okay, interest rate per annum. T can change. T can be in months also, in days also, in years also. If it is in years, directly number of years you can take. If it is days, then the number of days the loan is outstanding divided by 360. Or if it is in months, the number of months the principal is outstanding divided by 12. Like that, proportionately interest can be calculated if the loan is outstanding for a period of less than 1 year in general. Now let us just take this situation. Say if the same $100,000 is outstanding for only 15 days, then what we will do? We use the same formula. Principal is $100,000. P. I is same, per annum 6%. And now for T we have only 15 days. When it is only 15 days, 15 divided by 360. So 6,000 into 15 divided by 360, around $250 will be the interest that is going to be outstanding for 15 days only, if that is the interest. So if at all after 15 days the borrower has to repay, how much he has to repay? $100,000 plus 250. So $100,250 he has to pay. And on the other side, if the loan is outstanding for the entire year, then how much the borrower has to pay? $100,000 principal plus $6,000 interest, total $106,000 he has to pay. So that is how it can be calculated in case of simple interest. So for a simple understanding or a remembering purposes, you can just use this formula PIT. Principal amount, interest rate per annum, time you have to be careful depending upon the question. If it is number of years, just directly multiply. If it is number of days, then number of days divided by 360. If it is number of months, then number of months outstanding divided by 12, like that. That is the point here. Sometimes if this the amount of loan is outstanding for more than 1 year, then directly you can take multiplied with 2. You don't need again days for that and all. So here $100,000 loan for 2 years, right? So 1 year 6,000 means 2 years 12,000. What is the big deal in that? Same thing, 100,000 multiplied with interest into 2 directly. $12,000 is interest. So if at all the amount is outstanding for a period of less than 1 year, then we can use months or days or weeks also for that matter, depending upon the question. But if it is more than 1 year, straight away we can multiply with the number of years for which the amount is outstanding. That is the concept of simple interest. In a nutshell, it is PIT. That is principal multiplied with interest rate per annum multiplied with the time period. That is simple interest. But will that work most of the cases in the real world? No. In real world, mostly the interest is compounded. So more useful concept is compound interest. One of the main points of compound interest, as the name itself indicates, is here the interest gets added to the principal. And then interest is calculated on interest plus principal. So principal amount is a starting point, let us say. For one particular period of time, there is some interest. Okay. Second period interest will be calculated on this again, and that will be added. And next period interest will be calculated on this, that will be added. And next period interest will be calculated on this, that will be added, and this goes on. So compound interest is simply nothing but interest is compounded at regular intervals. So whatever the interest that has been accrued, which is not paid by the borrower, is added to the outstanding principal amount. So the interest is calculated on principal plus interest. Earlier in simple interest, interest was calculated only on principal amount. But here in compound interest, interest is calculated on principal plus already accrued interest, which was not yet paid. So that process is called as compound interest. And definitely compound interest will be more than simple interest in absolute terms. Why? Because in the original simple interest, the computation of interest happened only on the principal amount. Here it is happening on principal plus interest. So naturally something plus is only there here in the compound interest. So the compound interest amount will be higher than simple interest for sure. Now let us look at this situation as an example. Say $100,000 is deposited in a bank which gives 2% interest per annum compounded quarterly. So that is a point here. 2% compounded quarterly. So how this has to be understood? Okay, you deposited $100,000. First point is that. That is a principal amount. Keep it. On that 2% is the interest rate per annum. 2% is not interest rate per quarter. That is the point here. Most of the times people do mistakes. 2% is not interest rate per quarter. 2% is per annum only. But compounding is happening quarterly. So the interest rate is per annum. Compounding is not happening per annum. It is happening quarterly. There can be multiple ways of solving this. Let us just check this. Say, if it is 2% per annum, let us use the same simple interest formula. How much will be the interest for 1 quarter? $100,000. P. This is I. T is how much now? 1 quarter only. So 1 quarter only here means you can just take it as outstanding number of days 90 by 360 or 1 by 4. Easiest way is 1 by 4. So $100,000 into 0.02 into 1 by 4 will be $250. That is the interest for first quarter. That is interest for first quarter. Is it given? No, it is not given. If it is given, there is no compounding. If it is already given to the customer takes the $250 and goes home. Principal amount still remains 100,000 only. Next quarter also will get 250 only. Next quarter also will get 250 only. So there is no compounding in that case. That becomes simple interest. But here we are talking about compounding. So when it is compounding, one of the important factors here is to be noted. What is the frequency of compounding? We have to be very clear. In this case, what is the frequency of compounding? Frequency of compounding is quarterly. So first of all, how much is the First quarter interest $250. Now at the end of first quarter, how much will be there in the bank account of this particular customer? In our example, we are looking at a deposit scenario. Whatever it might be, the concept is same. How much will be 100 plus 250, $100,000 plus 250, $100,250 will be his new principal now, with inclusive of interest of first quarter. Now second quarter interest has to be again calculated. How do we calculate? Same way. Now principal, is it 100,000? No, it is 100,000 plus already this 250 is added to that. Now 250 has also become principal. That is what is compounding. Basically the interest also getting added to the principal is compounding. So 100,000 250, same thing. 0.02, same thing. 1 by 4. How much is the interest for second quarter? 100 250 multiply with 0.02 divided by 4. How much is the interest for the second quarter? 100 250 into 2% by 4. Is that one? $100,000 into 2% by 4. Earlier it was not 250, I think it was 500, isn't it? 500 actually. Yeah. 250 is not 250. No, this is wrong. This calculation you have to do separately. I thought, yeah, 2000 by 4, no, that is not 250. I was thinking 1000. So 500. So in the end of the first quarter, the amount of interest will be 500. Now naturally the principal amount will become now 100, 500. 100, 500, yeah. So 100, 500 into 2% divided by 4. Now how much is the interest? 502.5. That is interest for second quarter. That is also added to the principal amount. So at the end of second quarter, how much will be the amount that is there in the customer's deposit? 100, 500 plus 502.5. It will be 101,002.5. So $101,002.5 is the amount that is in the deposit of the customer. Third quarter interest, same way, it has to be calculated. How much is the third quarter interest? Calculate that carefully. That comes to around 505. Let us take 505 just for simplicity purposes. That gets added. Now, fourth quarter beginning or end of third quarter, how much will be the principal amount? Because 505 also is getting added to 101,002.5. So it comes to around 101,507.5, 101,507.5. Fourth quarter interest, how it has to be calculated? Way it has to be calculated is same. Again same, 101,507.5 multiplied with 2% divided by 4, it comes to around 507.5. 507.5. Add that to 101,507.5. You will be getting approximately 102,015. This is the amount which will be at the deposit bank account in this example of the customer at the end of 1 year. At the end of 1 year, when the interest is getting compounded quarterly. Interest was getting compounded quarterly. So interest of first quarter is added to the principal. Then on that original principal plus the interest of first quarter, we calculated second quarter interest. That is getting added to the principal. Again on the total we calculated third quarter interest. Again on that we calculated fourth quarter interest. And like this, all the interests, if we add to the principal at the end of 1 year, 102,015 will be the amount that will be there at the end of this period. Now the point is, do we need to do all this? Okay, this is for understanding purposes. How the compounding works, we understood this. But do we need to do all this? Actually not required. How to do the compounding in the cases where we have the present value tables? This is the important point. We have present value tables and future value tables. So what are we calculating here? First we should be clear. What are we calculating here? We are calculating what is the future value of $100,000 after 1 year. How much it will become? That's what we are calculating. So we are not calculating the present value of an amount that we will receive in future. We are calculating already some amount with us, how much it will become after 1 year if interest is compounded quarterly. So for that purpose, we need to take the help of tables or we need to take the help of formula. Either of them has to be taken. In this case, because the 2% interest rate is there per annum and compounding is happening quarterly, what is the interest rate per period? Per period. How many periods are there? 4 periods are there. Interest rate is 2% per annum. How much is the interest rate per period? 0.5% per period. Like that, how many periods are there? 4 periods are there because compounding is happening quarterly. But in the tables, do we have 0.5%? Generally, no. We start with 1%. That is why from the tables, directly, we may not be able to get that. But can we get that using the formula? Yes, definitely. That is quite possible. How? Now, original amount principle is there. 1 plus rate of interest to the power of n will give us what is the compounding of this amount. Of course, principal amount will be there anyway. That has to be multiplied with this 1 plus r to the power of n. What is r here? Interest rate per period. What is n here? Number of periods. Don't call it a year. It will be easier for you to remember also and understand and apply also carefully. When you understand r is the interest rate per period. R is the interest rate per period. How much is that? In this case, 0.5%. Like that, how many periods are there? 4 periods are there. How do we know that? Depending upon the data given in the question. Since there is a quarterly compounding, it is 1 year only we are looking at. So 4 times compounding will happen. And when the number of periods is 4, interest rate per annum is 2. Per period, how much is the interest? 0.5%. So how to compute this? 1 plus, again be careful, 0.5% means that will be 0.005 to the power of how much? 4. How much ever that may be, that will be the future value of $1. But we want future value of how many dollars? $100,000. So just multiply with the principal amount. Then how to get this? 1 plus 0.005 to the power of 4. It's a simple thing because it is only 4. Take this in the calculator. 1.005. 1.005. Okay. Multiply equal to. That means one time you have calculated already the multiplication. Again multiply that with 1.005. Again, whatever the resultant may be, again multiply with 1.005. So we multiplied the same thing for 4 times. So 1.005 to the power of 4 we need. So already 1.005 multiply with 1.005 multiply with 1.005 again multiply with 1.005. That will be coming to 1.02. Continue that because we need a little bit more decimals. Why? Because we have $100,000 here. 1.02015. Okay, at least to that extent you can compute this. 1.02015. Multiply that with $100,000. How much is the amount that will be? 102015. Is it not the same amount that we got here? Of course, yes. 102015. Same amount. So we can directly use the formula also. But once again, can we do all these calculations every time on the calculator? Again, it will be difficult. So in general, in the examinations, what happens is we will get certain numbers in such a way where we can refer to the tables. Point is, we should very much be clear that which table we have to refer and what is the concept we are looking at. In the time value of money, there are 4 concepts. Now what we are looking at is future value interest rate factors. Future value interest rate factors. That is simply nothing but compound interest. What are we looking at? How much $1 becomes after a certain period of time at a certain rate of interest. Simple. That's what is compound interest. And if it is less than 1 year, again the tables may not work. If it is years together, then the tables will be easier way to compute the future value or compound interest. And the number of periods is what we have to look at. So in this particular example, since 2% is there and interest rate per period is 0.5%, we could not find the value directly in the table. We could not do that. But if the interest rate is a little more, something like let us say 4%, then it would have been easy. Then it would have been what interest rate per period will be 1%. And how many periods like that? It will be 4 periods. So we will directly go here and say that yes, this is the future value interest rate factor. That is FVIF. FVIF is nothing but compound interest. What are we looking at? What are we computing? That should be clear. We are computing how much $1 will become in future. $1 when you started, now present value is $1. What is the future value of that $1? How do we know that? That can be known by taking 2 things. What is the rate of interest that we are contemplating? It could be rate of return also, not necessarily interest always. For simplicity, we are calling it interest. And for how much period? How many time periods? If these 2 things we know, straight away we can go to the tables and find out what $1 will become. And if you know how much $1 will become, you can easily know how much $100,000 will become, how much $50,000 will become, whatever the amount that we are looking at. That can be easily computed by looking at the tables. That is the point here to be noted. And that is the concept of this compound interest, simply speaking. Of course, because compound interest is calculated on principal plus interest, it will be always higher than simple interest amount wise if you see. That's what is compound interest, or simply we can call that future value of a certain lump sum amount that is deposited now. Because the topic of future value has come, I think we will just go to the future value first, then we can come to the present values later. Though we actually use present value more than future value, but concept is same. Why? Because these are 2 just reciprocations, right? What are the reciprocation? Just like earlier what we observed, if some amount is there now, how much it is becoming later? It is becoming original plus something. How much is that something? That depends upon rate of interest, time period, simple interest, compound interest, whatever it is. But definitely the principal amount is becoming principal plus something. This is future value. This is future value. And what is the future value of this P plus X? That is P. That is present value. So both are just related with each other. And if you formula wise also, if you look at $1 becomes after some time how much? What is the amount that has to be considered to be the multiplication factor, or FVIF if you take? As we have seen, that is 1 plus R to the power of n. So present value is nothing but whatever the amount. Sorry. The future value of something, future value of 1 rupee is nothing but that present value multiplied with 1 plus r to the power of n. In other words, present value of the same amount will be how much? Future value divided by 1 plus r to the power of n. So both of them are interrelated with each other. So compounding, when we look at, automatically the reciprocation of that is discounting. So in the first scenario, we call this compounding. In the second scenario, we call this discounting. Both are just reciprocation of each other. But essentially, we have to understand something. If, for example, $1 is valued $1.18, or it is becoming $1.18 after some period of time. In our first example, we have taken as 3 years, whatever the way of computation of interest may be. That automatically means the present value of $1.18 now is 1 rupee. When this $1.18 will be received? After 3 years. So after the end of 3 years, if you receive $1.18, what is the present value of that now is only $1. So present value is always lesser than the future value, and naturally future value is always more than the present value. Why is that? Because future value is compounding, present value is discounting. We'll come to the present values later. Before that, let us go to the future values first, since we are already talking about future values. So what is this future value? Simply speaking, it is looking at an unknown future value or a single amount of money or stream that is invested for certain period of time. So here also we have to look at whether it is for present value, whether it is for future value. We have to look at two possibilities. So one is a single stream of payment or receipt. Second one is multiple times of payment or receipt. In case of single one time, then what concepts we use are PVIF or FVIF. Then if it is multiple, what concepts we use is PVIFA, annuity, that is, or FVIFA. Once again, A is here indicating annuity. So what is annuity? Annuity is a periodic payment or receipt. Periodic. In our original example, what we have taken, $100,000 is one shot. Was that $100,000 being deposited every month? No. Was it deposited being deposited every quarter? No. Was it being deposited every year? No. It was deposited only once. So deposit is happening once. Compounding is happening multiple times. So what we can take there? Simple. Only one thing, that is FVIF, which we have taken already. So that is single stream of payment. A single amount of future value of $1 will be how much? That is nothing but compounding of one particular amount at a particular rate of interest for a particular time period. How do we do that? As we already done, same thing will be applied here. It is FVIF, future value interest rate factors, if you look at tables. Otherwise, formula, again same. Formula is whatever the principal amount, multiply with 1 plus r to the power of n. R here is what? Once again, I'm repeating, it is not interest rate per annum. It is interest rate per period, depending upon the periodicity of compounding. So interest rate per period is R. That is R. Then what about N? N is number of periods, number of times the compounding is happening in total. So this, if we are clear, application of this formula, or even for that matter tables, will be easier. Tables, if we can use them, that is the best way, because it is easier. Otherwise also, by using simple calculators, we can compute these things when the numbers are in front of us. Let us look at this example. If John invests $100,000 now for 5 years and does not touch it, is only investing $100,000 now. So this is the principal amount, okay? And if he receives interest on it compounded annually, annually is a simple thing. Straight away we can go to tables also, no problem. At a rate of 6% per annum, how much will he receive at the end of 5 years? How much will he receive at the end of 5 years? Depends upon these two factors. What is R here, what is N here, that we should identify. Principal amount we know, that is $100,000. Keep it aside, that is okay. 1 plus R, how much here? R is interest rate. What is the time period of compounding? Compounded annually. So interest rate also per period 6% only. So 1.06. That is 1 plus r to the power of how many years? Like that, 5 years. That's it. Can we do it in the calculator? Yes, you can. Multiplying 1.06 into 1.06 into 1.06. Or if you are using a simple financial calculator, you can just directly compute to the power of 5. 1.06 to the power of 5. That way it can be computed. But is it required? Not required. Why? Because how much is this amount is already there in the table. All that we need to do is refer to the tables. Simple. In the tables, what are the two things only we need to look at? It's a two-dimensional table, 2D, not a 3D one. It's only 2D table. What are the two dimensions you should look at? One is rate, one is time period. Here what is rate? 6% per period. Number of periods is, because it's annual compounding, 5. That's all. 5 years, 6%. So before going to table, you should keep this in mind. 5 years, 6%. Okay, 5 years, 6%. Now, let me go to 5 years. Okay, this is 5 years. Where is 6%? This is 6%. Done. I got it. 1.338. Straight away. So 1.338 is the future value of $1. How much will be the future value of $100,000? Just multiply. So it will come to approximately $133,800. So that is the future value. So if somebody invests $100,000 in a bank account and after 5 years how much you will get is $133,800. Simple. That is the future value of $100,000. That is the point to be noted. And of course, as I said, it can be done using formula, or if possible, it can be taken directly from the tables. Usually tables will be useful because in the exam questions, mostly the way the question will be framed will be in such a way that you will be able to use the tables, and tables will be available also. So no need to separately calculate and waste time on any of these things. Straight away going to table and getting the FVIF. Main point here is what are we calculating? That should be clear. What is this? 1 plus r to the power of n. What is this? That is FVIF. So you have to go to that particular table particularly. So where you will go? You will go to this table, future value of $1 table. That is FVIF, not annuity, single payment, one shot payment. So $1 now invested after 5 years. If it gets a return of 6% compounded annually, it gives $1.338. That is the meaning of this 1.338. That should be very clearly understood. Mechanically, if we do, most of the cases we solve the questions wrongly. That is the biggest danger in this. That is the reason why time value of money concept has to be very clear. Now that is the future value of $1. If the possibility of, let us say, looking at the tables is not there, we know already how to do that. Simply 1.06 to the power of 5, that can be taken, and we will get around this only. How can that be done? Easy. This 1.06, 1.06, okay, into equal to, that gives what? 1.06 square. Again multiply, equal to, that gives 1.06 to the power of 4 into 1.06. Same thing, 1.33822 it will come. So 1.338 can be easily found out by taking calculator also. Of course, if it is like 30 times, 40 times, 20 times and all, calculator will be definitely not preferable, because some step missed will get wrong answer. Still, once again, let me reiterate, the questions in the examinations will be in general in such a way that you will be able to use the tables. Rarely only questions will be framed in such a way. Tables are not useful. But worst case scenario, even if the question is in such a way that the tables are not possible to be used, like we had earlier, like 0.5% was per quarter, like that 4 time periods are there, you cannot use tables, because in the tables there is no 0.5%, that's starting with 1%. There you have to use normal calculation using calculator. That is okay. That's about one time amount invested. What is the future value of that? That is a point here to be noted, one of them. Now coming to the another important aspect here, that is the future value of an annuity. Future value of an annuity. For that matter, annuity, any of them, is about a regular stream of cash. Out or in doesn't matter. For a depositor it is let us say outflow, for a bank it can be inflow, and vice versa. So outflow or inflow depends upon the party. We don't have to much worry about that. We have to think about the concept. If you are looking from an investor's point of view, you are depositing money. That's an outflow for you. Let us say for a banker point of view, that is inflow. So point is same, computations are same, direction is different. There will be always opposite directions. Otherwise, how can there be financial transactions in the world? So don't worry about the directions while understanding the concept. Directions are important in computations. Plus or minus is a very important thing. But when we know who is the party. But here, for understanding concepts, we don't need to know who is the party. For understanding concepts, we need to know only what is the meaning of it. What is the meaning of it? Future value of an annuity means what? It means some person. Let us take an example. Let us say somebody deposits $1,000 at the end of each month. Okay, like that he has some salary of say $6,000 or $7,000. In that he wants to save $1,000 each month. Like that he will invest for so many number of months. Example I'm telling. Okay, then how much money he will have at the end of that period? Let us just take this, because anyway I have taken this example. Say he does this for 6 months. Okay, he does this for 6 months, let us say, as an example. $1,000 each month he will deposit in a bank. Sometimes it is called as a recurring deposit, whatever the names we give. Or if you invest something in a mutual funds, it is called as a systematic investment plan. Same amount. That is important aspect in annuities. Same amount will have to be either given or taken at a periodic intervals with the same period. We cannot say I'll deposit now $1,000. After 2 months I will deposit again another 2,000. I will wait for 4 or 5 months. Then I will deposit 500. Calculate my returns. No, that is a different calculation. It has to be calculated separately. Tables and all will not work there. It can be calculated, but we cannot use that. So when we look at an annuity, it has to be the same amount. That is an important point. And for same periodicity. The same amount and same periodicity are the two important aspects of annuity. Now, can we use an annuity concept here? Of course, yes, because same amount and he is depositing monthly. Now, all the other things what we need, period we know. How many months he did that? 6 months he did that. Logically, just like forget about interest and all. How much money he will definitely have at the end of this period, after the period of 6 months. $6,000 for guaranteed. Na? That is okay. But question is not that. Plus something also will be there. That is interest. How much? How much that can be computed? How? By taking future value interest rate factors annuity. This is FVIFA. FVIFA, future value of $1 annuity. Okay. Annuity is nothing but periodic payment. So how much that can be computed as? That can be computed using the formula also, but I don't suggest that. Why? Because it is more complicated, unnecessary also, not required. So simply let us use the tables. That is easy. What we should do to understand how much the 1,000 periodically deposited for a period of 6 months become. 6,000 plus something, that we know, that is okay. But how much, that we don't know. We need to know two things here. One is time period as usual, and other one is interest rate per time period. Let us, the time period we know, that is 6 times, right? 6 periods, monthly, 6 months, so 6 periods. Always keep periods in mind than years, that is easier. So then, how much is the interest rate per time period we should know. Per time period. For simplicity purposes, let us take interest rate is, say, 12% per annum. If you take anything other than that, again it becomes difficult. Why? Because per period we need at least 1%, because our tables are starting from 1%. So let us take interest rate per annum is 12%, which means per period how much? 1%. Per month. In this case, this is the period, that is monthly. So per month, that is 1%, which is per period. So forget about month, quarter, year, whatever it is. Per period, how much is the interest? So same things we need. Always we don't need any big things. We need R. we need n. What is n? Number of time periods. What is our interest rate per period? That has to be clear. Number of time periods here is 6 times, 6 periods. Got it? Very good. How much is our interest rate per period is how much? Per period is 1% because per annum it is 12%. Now all that we need to do is, when we know these two, all that we need to do is to go to FVIFA tables and look at that. 6, 1%, 1%, 6, 1%, 6, 1% is this, okay. 6 is this, okay, that's all. 6.152 is the FVIFA. Understand that. That is not just one-time investment. It is periodic investment happening multiple times. So 6 is guaranteed. 6 plus something, 0.152 also is added. So in this case, $1 invested 6 times will give $6 anyway. But now how much it is giving? It is not giving $6 only. Plus interest is also there. That inclusive of that interest, how much it is? 6.152. So this 1000 becomes how much? Naturally, $6,152. So what is the interest component in this? $152. 6,000 is principal, 150 is interest. So now we know our answer. 6,000 is okay, sir. How much extra you will get? You get additional $152 also. That's it. That is future value interest rate factor. Annuity. When can we use that? When same amount of money is being deposited over a period of time for a certain number of periods. And when we know the number of periods and we know the interest rate per period, automatically we can apply this future value of an annuity amount. Of course, certain points to be noted here as we already discussed. One thing is the amount which is supposed to be received or paid has to be constant. It cannot be changing. That is first thing. And periodicity. At what time, same point of time at each period, it has to be there. And interest has to be naturally compounded once in each of the periods. Then only it will be usually taken as future value interest rate factor annuity.